Understand trig there.
For which part when I was saying?
All of it.
Horizontal vertical distance?
Yeah. For someone who said it doesn't get trig, I've never gotten it. I can't get it.
I'm getting it now.
Yeah.
You're a
I
better
know.
teacher than my old teacher.
I like it. I like it.
Times this. No, times 360 because that's a full circle of degrees. The amount of degrees. This is one circle. This one has 2 sine, right? So this one's going to be.
Is everybody working on number 5 or done? Okay, just make sure everyone's on 5. How's the homework coming around? Let's see. We got stacks still moving? Okay, 3 should come by you. 3 stacks. Okay, let's do number 5 together. So most of you have even at least thought about it, taken a look at it. So for number 3, we want to first sketch the vertical distance above the horizontal diameter. Okay, and it says that the bug makes it around in 5.9 seconds. Okay, so my hint to you was, if we look at 5.9 seconds, we know that one cycle, so here's 5.9 right about there. Basically, both a cycle of sine and cosine we can think of in 4 parts, right? 4 parts. So what is 5.9 divided by 4? Anyone get that number? 47? Just shy of 1.5. Is that right? So just a little bit less than 1.5, so then just a little bit less than 3, and then somewhat more or less than 4.5. So I keep adding 1.48 each time, and after doing that 4 times I get 5.9. Does that make sense? So I took 5.9, 1.48 equal spaces. So this is vertical distance above the horizontal diameter. Is that like sine or cosine? Sine. So where will his vertical distance above the horizontal diameter start at time equals 0?
0.
It's 0, right? In the first quarter cycle, what will the bug do? Go up or down? Up to what? 1? Okay, 1 or 8? I asked for this in terms of feet, right? I said I wanted it in feet. So in feet, he'll go up to 8 feet. If I said radius lengths, he would go up to 1. But I said 8 feet. And then in the second quarter, what will the bug do? Back down to 0. This is like quadrant 2. So you imagine the bug, he's going up to the top. And then in the second quarter, back down to 0. Let's do this in blue. So do it in blue. So here's where he starts. Then at 1 quarter cycle, which is 1.48 seconds, up at the top. In the next quarter, back here. Then the next quarter. So first quarter to the top. Second quarter to the midline. Third quarter to? Down to negative 8 feet. And then in the last quarter, back to 0. So straight lines, boom, Boom. No, we worked that all out. That it's what, increasing with decreasing changes, and then decreasing with decreasing changes, more negative, getting more negative, then decreasing with what kind of changes are those? Increasing changes, becoming less negative, and then, so there's our rough sketch. There's our rough sketch. So now let's build the function, and I'll tell my graphing software to graph the function, and we'll see how we did. Okay, so building the function then, we know it's what kind of function? First of all, sine. What is the input into sine? What is that in parentheses, whatever goes into input, what will that represent? Angle, right? That's angle. But we need that angle as a function of t. So that will look like this, right? So that angle will look like b of t. So the question is, what is this coefficient b? So we have some information we can solve for b. We know that at 5.9 seconds, what angle should we be at? 1 rotation, right? So 1 rotation, we should be at 5.9 seconds, which allows us to solve for b, which equals 2 pi over 5.9. So what is the argument, or what is the angle into sine in terms of t? 2 pi over 5.9. I might as well just start typing this here. So we got y equals sine of 2 pi divided by 5.9. So here my time is the x. So that's going to be x for me. Is this going to get it right?
No. So wait, is that 2 pi over?
Okay, so hope we're confident multiplying fractions, right? This is the same thing as 2 pi over 5.9, right? 2 times a fraction is 2 times the numerator. So everything's cool there, right? So if you want me to move the 2 over, I can move the 2 over. Okay, does that make you happier? Okay. Same thing, right? 2 times a fraction is 2 times the numerator. Okay, is this going to get us the graph? Yes or no?
Don't you want it in feet, so you would need to put the
What's the output now?
radians.
Not radians.
Radius length.
Radius lengths. Radius lengths. And we want feet. How do we get feet?
You put the radius length.
Which is? Did anyone come up with that function before I started? Did you get that? 8 times. Good. So if you got this function before I started, that's good. And the x would be t. Your x would be t. So 8 sine 2 pi over 5.9 x. If I graph this, it should look like our blue graph. Okay, but showing more cycles, right? So we just drew 1 cycle, but we nailed it, okay? We got it. Does it make sense? Okay, anybody have a question on this? All right, so this, we'll just go ahead and finish this on separate paper for Wednesday and include it with your homework, okay? So just redo this on separate paper, stick it in with your homework to be due Wednesday, okay? Period. So in this graph, what's the period of this graph? So period is the numerical value of the width of a cycle, or it's how the width of input values that give you a full cycle of output. So what's the period here? 5.9. So just the plain old sine function. What width of input gives us a full cycle of output? 2 pi. 2 pi. But here, this is 5.9 seconds. Does that help, Riley?
Yeah.
Okay. Other questions? Okay, another thing on Wednesday is we will have a quiz, and I'm gonna do the quiz right now. I'm gonna show you the quiz. This is it. Okay, and it's to do the unit circle that we worked on last Monday, I think. So we'll do it together. Any way you want to remember this, it's up to you, but here's a recommended way. So we'll start with all the radian measure of angles. Okay? Okay. So we're going to start with the radian measure of the angles. So we'll start right here. How many radians?
0.
0 radians. Okay? And then in order to get these nice symmetric angles, we started with what angle? Gave us all these nice symmetric angles on the circle. We said, how many radius lengths does it take to get where? Halfway around the circle. Pi. That's where we started. Pi is defined as the number of radius lengths that you lie around the circle to get you halfway. A little bit more than 3, right? Because we said when we did 3 put us about there. Right? And we were interested in exactly halfway. Because the whole values don't land in nice places. So we start with this very nice place, halfway around is pi. So then from there, we can easily get at the top of the circle. Okay? Bottom of the circle. All right, so that's where we start. Now the next thing I suggest is to do the fourths. Okay? So we're going to break up pi into fourths. So which one is a fourth of pi? 1, 2, or 3? In the middle. So now you can just count. Just count. This is 1 pi over 4, 2 pi over 4, 3. Next one is 4 pi over 4, which is just pi. Then 5. 6, 7. And then 8 pi over 4 is 2 pi, but it's a rotation of 1 full rotation. So 0 and 2 pi are at the same place, but they're very different angles, right? 0 means no openness, right? 2 pi means a full rotation. Okay, so so that they've got a spot for that even there too. Okay, good. So 2 pi. Good so far? So now I suggest do the sixths and just count 6. So starting with pi, where is 1/6 of pi? First one, right? This is 1/6. Now the sixths don't include the fourths. So we're going to skip the fourths. So this is, count with me, ready? 1, 2 pi over 6. We'll come back to that later. 3 pi over 6. Let's just write it down. So 2 pi over 6. Then 3 pi over 6 is the top. Then 4, 5. Skip the fourths, right? 6 pi over 6. Does it make sense? Yep. This one? 7, 8, 9 pi over 6. Does it make sense at the bottom? 10. All you got to do is know how to count. 11. 12 pi over 6. And always check with these ones you've done before. 12 pi over 6. Does it make sense? 12 pi over 6 is 2 pi. Okay, now these, there's 4 of these that can simplify, right? So 2 pi over 6 simplifies to pi over 3. 4 pi over 6. 2 pi over 3. This one, 8 pi over 6. 8 pi over 6 simplifies to 4 pi over 3. And then 5 pi over 3. Radians. Questions on radians? Those are the radians. So count your fourths. 1, 2, 3, 4, 5. So, oops, 1, 2, 3, 4, 5, 6, 7. Those are the fourths. Then the sixths, you got to skip the fourth. So 1 pi over 6, 2, 3 at the top, 4 pi over 6, 5 pi over 6, 6, 7, 8, 9, 10, 11, 12. And then just simplify those 4 in the tall vertical rectangle. Okay, degrees. Start with 0, easy. Okay, halfway, pi. You all know this. I did a 180, right? I did a 180. That means you turned around. Half a circle. So a full circle is? You all know what a right angle is. 90. Okay, so the bottom is halfway between 180 and 360. Or just add 90 more to 80. Add 90 more. Okay? So the fourths, do it just the way you did the angles. Go by fourths. The fourths will be 45 at a time. So 145, 2 45s, 3 45s is 135. 4 45s. 5 45s. Or just keep adding 45 each time. Add 45. Add 45, 315. Okay, pi over 6 is how many degrees then? It's 1/6 of 180. 30, so just keep adding 30. 30 plus 30 is 60 plus 30, 90 plus 30, 120 plus 30, 150 plus 30, 180, 210, 240, 270, 300, 330. Question on degrees. So just add 45s, add 30s. Make go around twice. Okay, well, we'll just do the first quadrant of cosines and sines, and then the rest you should be able to do on your own. Okay, so we'll just do this first quadrant. So, what is the cosine of 0?
0.
Better know this, 1 or 0. Cosine is horizontal distance from the vertical diameter, it's 1. Sine of 0. Vertical distance to start with is 0. Okay? Cosine of 90.
0, 1.
Sine. Vertical distance in radius lengths, right? All right, let's do pi over 4 next. So pi over 4 is where the sine and cosine is equal. Yep, that was that. Now, so lots of people will initially think, oh, it's a half, but it's not, right? It's further than half. It's like 0.707 this way and 0.707 up. So what's greater, cosine or sine here? What's greater, cosine or sine? Is the horizontal distance or the vertical distance greater? Horizontal is greater, so that's your radical 3 over 2. And you can see if you tracked over here, it lands exactly at 1/2 of a radius length up. And over here, now the sine is greater. It's radical 3 over 2. And the cosine is 1/2. The rest of these are just, do them later, okay? Don't do them now. The rest of them are just putting the right negative or positive based on, so over here in these quadrants 2 and 3, cosine will be negative, right? Because you're to the left of the vertical diameter. So all the cosines, all the x-coordinates will be negative over here. Where will all the sines be negative? Below the horizontal diameter. They'll all be negative down here. The y-coordinates. Okay? So I will hand you a sheet of paper just like this. And you'll have 5 minutes to finish it. Okay, so the point is not to get some points on a quiz. The point is that from here on out, whenever you're dealing with these angles come up the most often in problems, okay, and in calculus all the time. So you want to just have these at your fingertips. You don't have to get out a calculator. And when you get out a calculator, right, you don't get an exact value. You get an approximation, unless it's 1/2, okay, unless it's 1/2. So you want to know these exact values for sines and cosines for all these angles. Any questions about that? So if you have a different way of remembering it, that's fine. This is my way of remembering it. Okay, are we good? Okay, so let's Press on to open up to page. Okay, so this afternoon I may change the homework assignment. Anything that you've worked on, if I take it off, it will be due eventually, so it wasn't wasted time. But just check this afternoon for a finalized homework assignment, okay? Page. Page 288. So let's talk a little bit before you dig into this, okay? So it says, a bike is on the rack at a bike shop so that the technician can turn the pedal with his hands. Okay, so the pedal here is on the left, turn the pedal with his hands, causing the bike's back wheel here on the right to rotate. For every 1 radian that so I'm going to do 1 radian, so for every 1 radian that the pedal turns, so that's about 1 radian, the valve, did you see the valve turned 4 radians? Okay, let me do it again. So if I turn it 1 radian, it's very hard to control. The valve turned 4 radians. Okay, so likewise, here. Every time it goes a radian, the valve goes 4 radians. Oh, I forgot to show you. It's the pedal and the valve. Okay? Forgot. All right. So our goal here is, let me give you a final goal. So we've so far talked about things like this. We had our sine of what? 2 pi over 5.9 t, right? Where t was time, and then what was that whole thing in parentheses? Yeah, the whole thing was radians, right? The whole thing in parentheses was an angle. So we had a little function here that gave us angle as a function of time. Now, another possible way that we can see the input is something like this. Sine of just b theta. Okay, so the input is still theta, but what's going into sine is a different theta based on what the b times theta is. So we're still inputting theta, but what's going into sine is a different angle, b times theta. Does that make sense? So we are a different angle than theta. So, so far we've done that. So now we want to investigate, so what does it mean just to have a new expression of theta, so that our input is not time anymore, but it's theta, but we have a new expression of theta, of a different angle, going into sine or going into cosine. That's what we want to investigate now. So that's why we got these 2 different angles. We've got theta, the angle that the pedal's turning, and then a corresponding angle to that, that's what the valve is turning. Okay? So that gives you some setup. That's what we're investigating here. So I want you to do, you can skip A. You've got the image right there. But you can redraw the image if you want for A. And then I want you to work through number 4 and see how, all of number 4, so that's a page and a half. And see how it goes, okay? See how you do. And I'll just let it spin. Okay, how's the homework going around? Did everyone get 3 stacks? Okay, where are the leftovers? Yeah. Oh, yeah, who didn't see the homework? All of them or just? Okay, so what for part C? Function that outputs the horizontal distance of the pedal from the vertical diameter. What will that be? So all it's talking about here is the pedal. Nothing about the tire valve, just the pedal. What's that? I did. Thanks. Thank you. All right, so what will this, we're going to graph the horizontal distance of the pedal as a function of the angle, and in radius lengths, as a function of the angle that the bike tech turns the pedal. And that's F, right? What is F? F of theta. What function is that they're asking for?
Cosine.
Just plain old cosine theta, because input is the angle theta, output is in radius lengths, horizontal distance. Okay, and we know what that looks like, right? Where will it start? When I start this rotation, where will the cosine start? What's the value at theta equals 0? 1. Right? And then 1 full rotation, the period is 2 pi. So that's your F graph, F of theta. Okay? And then they asked you for, what did they ask for? G, function G. So before that they said, when you turn the pedal theta, what angle does the tire valve turn? Yeah, 4 theta. So the angle that the tire valve turns is 4 theta. Okay? So if we want the horizontal distance in radius lengths, it's going to be the cosine of what? 4 theta. Was that a question that they asked? Okay, so the question is, what will that graph look like? What will that graph look like? So what does the tire valve do over 2 pi, one period of the angle theta? What will the tire valve do? So it goes up and down and back how many times? 4 times when theta goes through 1 cycle. So you have it on? Yeah, so here we go, ready? So when the pedal goes 1/4 of the way, it's already made a full cycle. It's already made a full rotation. Halfway, another rotation. 3/4, another. So it'll make it around 4 times when theta just makes it around once. So what's the period of G? What's the period of G? 4 times is great? No, 1/4 as much, right? Because now it takes 1/4 of the angle to get a full rotation of the tire belt. So the period is pi/2. That's one period from there to there. And so when you multiply by 4, what happens to the period of your graph? It's 1/4 of what it was. And so this thing with the tire belt should help make sense of that. Because if you're multiplying by 4, it's going around 4 times as fast. So that period is going to be 1/4 as long.
And the period of F is only 2 pi, right?
Still 2 pi, yeah. Okay, look for updates to the homework assignment this afternoon. We'll see you Wednesday.